So it's very different from what you've seen before. This is more of how I envision a system to be. So I'm very low level as well. So you read a lot of papers, and it says, oh, this is a great idea to do this. This is a great idea to do this. And I sit down and I start diagramming it on my whiteboard because I'm an engineer. I like to sit there and diagram things out. And it's like, well, then all these problems arise. So I just kept sitting there and drawing, and well, what would I do? And this is kind of the culmination of all of that, where I just kept working and working on the nights and weekends after classes and things like that. And just kind of came up with the framework that we're going to see. Now, originally I thought that there'd be a background in blockchain, so as I was listening to some of the questions, I was modifying my slides to hopefully provide more information as we get going. I'm also going to skip through some things so that don't get bogged down in the details. But anyways, so here's kind of an overview. I'm going to talk about the framework that we're using. At the end, it's a demo, proof of concept. It's not as good as the other ones. I apologize. Okay, but it works. So it's just an implementation of the non-trivial elements. So I didn't use Hyperledger or anything like that. It was just me. I built a couple of communication devices, but mostly it was about the cryptography, how we can share the information, how we can make modifications, as we'll see as we go through. All right. So a quick overview. Thanks to the other presenters, we have this covered, right? So blockchain has the potential to disrupt many different industries. Healthcare is not an exception, all right? But if you looked at the literature, a lot of it is very abstract. Oh, it'd be great to use it. No, you cannot use it. Or it's just very limited. We'll do X, Y, Z, very, very small. And nobody really agrees on what you can and can't do in healthcare. A lot of people say, well, it's HIPAA. You know, HIPAA. You can't do this with HIPAA. And I'm a health informaticist, so I've worked in a hospital for 3.5 years, worked for college nursing for 1.5 years. I worked with all their data. And we were very cognizant of HIPAA, obviously. So I kind of took the principles that I learned and that I teach and integrated them into the systems here. There are the challenges I just spoke about, the data privacy and security, exchange of information. Sorry, I'm a wanderer, and so if I seem like I'm on a wander, I like to walk back and forth, but I was told to stay kind of in this area. So here we're going to kind of talk about the blockchain framework that we're working on, that I'm working on. Just kind of give you a couple proposed solutions, and then there's a demo at the end, a little proof of concept. Okay. So what's the value, first of all? What's the value to patients of this system? This is a patient-centered system. This isn't an EHR replacement. Okay, this is a supplement and something that we can use to get patients actively involved. Yes, we have PHRs. We'll kind of see that. It's not really taking off. And why is that? Mostly it's because we can't exchange that information. Most people, what do you have to do with the PHR? If you keep all your records in your own personal health record, you got to print it out and take it in. Okay. So how can blockchain help with that? The patients can accumulate all their records, okay, into one central location. They're actively participating. They're adding records. They're pulling things in from the hospital, from urgent cares, from the dentist, from chiropractors, from say nature paths, whatever. They're adding their vitamin lists. They're journaling. They can do whatever they want. Add information. I have my personal shaming device, my Fitbit. Just tells me how lazy I am. It's not that many steps most days. And you can add all that information in there. You can add and receive documents. You can cryptographically sign them. And then there's the potential to connect to support groups in here as well, because you have your own cryptographic identity. It validates who you are, but it's still anonymous. So it's basically you can join these support groups anonymously in the blockchain. For providers, it's you have access to patients' comprehensive medical records. Okay. So how's that going to help healthcare to begin with? Well, if you just have the records that you have, maybe you're missing a lot of things. Maybe you're missing an allergy recorded at another hospital. Okay. So my daughter has a severe allergy. It's recorded at one location. That location does not share the information with Vidant. If she ever goes to Vidant, they're not going to know that if they give her penicillin, it'll probably kill her. Okay? So she has to have what? A medical alert bracelet, just so they know. Now, if everything's in the blockchain and everybody connects to it, then they can just grab her records immediately, consume everything, put it in, and they have all her information. Okay? Interoperability. Now, I've worked as an informaticist from like the low level of the computer systems perspective, so for me it's all about interoperability. I spent a year cleaning data sets for the College of Nursing at the University of Iowa. 3 hospitals with the data, cleaning them, integrating them, merging codes. Oh, it was a nightmare. I had hair back then, okay? It was pretty rough. Okay? So if we can use something like FHIR, HL7 FHIR, it's a standard for creating records for, it's just a format. It says export from your information, your system, into this. It doesn't matter what you have. Export to this standard that everybody can read and write. Otherwise, you have 500 different type of export and import, and it's just very difficult to exchange information that way. If everyone exports to one standard, put your information in this format, then everybody can read it. So our system is built entirely on FHIR. the open source standard. It's a means of patient authentication, which is great for diminished deter fraud and abuse, because you have that identity that says, this is me, and it can be validated. You also can track patients' adherence to protocol. So are they actually walking? Well, my Fitbit data will go into my interface that'll be uploaded to the blockchain, and they can check yes or no. You can do blood pressure cuffs, say anything with Apple Health Kit, and so on. And so on. There's a lot of different things here. Okay? And I like the back one because I'm a technologist. It's that real-time backup element as well. So all that information is being backed up continually. And for researchers, any researchers in here? Great, okay. So for me, this is like the most exciting part. It's all that information that's available. Okay? Just think about it from public health, population health. If you're looking at disparities research, or you're looking at rare diseases where you might not have enough people at one hospital, but if you look across the entire state, for example, now you suddenly have a sample size you can actually work with. Interoperability again, because it's a big thing for me. With those support groups, you can blast out emails to them, big kind of emails. So those who subscribe saying, hey, we're doing this and this. So if you're interested in sharing data, participating in studies, they can send messages out to you, and it'll be an easier way potentially of collecting samples for your studies. And you can send and receive information, and yeah. So this is the new stuff. So as I was talking, I was copying and pasting from other old slides. So you got to get a brief background. I'm going to go through this quickly. So it's all visual, okay? So this is a block. You have data, previous hash, and a hash, all right? There's the data. It's just stuff that's in there. That's what you're storing. It's just monetary transactions. This is from an old talk, so I didn't have a chance to modify it. But the big thing here are the fingerprints. Okay? The previous hash is the block that you're connecting to, and you grab its fingerprint. Whatever's in the block, you fingerprint the block, and that's its identity. There's the fingerprint. Now for this block, it's a function, as you can see up here. All right? We're not going to talk about the function, but basically, that's how you compute its fingerprint. And it's different than the previous one. Okay? And then we take this block, and you can change the next block by taking its fingerprint and locking it in to the other one. So the fingerprinting is really important. I'm going to be talking about that a little bit later in terms of how we can solve some of the problems with changing blocks. All right? Now what happens if I change the data here? If I change the data, I change the fingerprint. If I change the fingerprint, I break the chain. So that's a security feature. If I change anything in a block, the chain is broken permanently. Right? Now, as we heard Mark talk about earlier from IBM, he's pointing actually at me. And he said, if you are manipulating the block, if you have bad data, then we'll just cut you off, and then eventually it's kind of a self-healing environment where you pull the information down from other valid blocks, and then you correct yourself. You fix the data. So instead of having bad data, you have the right data again. And what's a blockchain look like? Well, you start with what's called a genesis block. That's from the paper. You always have to have a previous thing to connect to. What do you connect to? Well, they call it the genesis block. It's just there. It just starts there. And then you're just chaining it together. That's a block chain, visually. Literally have blocks that are connected together. All right. Hopefully that makes sense. I wasn't intended to talk about this, but we're going to make some changes to this in terms of our framework. All right. So it's a 5-part framework that we're proposing. The first part is private, and thanks to IBM. I don't have to talk about that right now, which is good, because they mentioned, why would you want a private network as opposed to public, okay? It's confidential information. You can have a private network. And we're using nodes and miners, but from trusted third parties, hospital systems, research institutions, universities, governments, and so on. And they would sign a legally binding agreement, such as the Business Associates Agreement, if you're familiar with that in healthcare. And they would, instead of signing with every other institution, you can create kind of a central entity, like a regional health chain organization, if you know about regional health information organizations, or RIOs, that manage health information exchanges, similar in premise to that. If you don't, then don't worry about it. They're responsible for lots of things, but in terms of patients, adding patients, we're not going to let just anybody create a wallet like you would with Ethereum, for example. Okay? You only want patients, validated patients, that go to those hospitals, for example. And you can just follow the exact same process you do now for patient portals. So nothing changes in terms of signing up individuals to use this system. Now here's an example. These are 7 counties or groups of counties. And this kind of shows you, I'm going to skip to the animation, but it just kind of shows you how the network would look. Everybody's connected to everybody else. It's fully connected. And actually, each one of those locations, we didn't pick them at random. We went through and we found universities or research organizations in those actual counties that might be interested in participating in this network. The little second bullet point there, the Pacific Research Platform, has anybody heard of that? I haven't been in a single room where anybody has. Okay, anybody here heard of Internet 2? Okay, good. This is an implementation of Internet 2 in California. It's a high-performance computing network. It's 2 years old. It's proven. They're able to transfer from San Diego, where I'm from, to San Francisco, 500 miles away, at 10 gigabits per second sustained. That's faster than my hard drive and my laptop can access itself. Okay? They're breaking down the barriers in terms of exchanging information. So one big challenge, one big question you always hear here is, well, how do you exchange large files like MRIs? Well, right now we're kind of limited. So in the blockchain, you just put pointers. That's kind of the way we do it. You just point back to the large files and say, you can go bid it here. But if we eventually have these high-performance computing networks, you can, in real time, basically exchange these files and do analytics on the fly in real time. So this is actually happening. And it's not just in California at 10 gigabits per second. They're communicating with South Korea, Japan, the Netherlands at 5 gigabits per second sustained, which is massive. That's like sending a DVD in a couple of seconds. Okay? It's a lot of information. That helps build a network. Second, like I said before, it's patient-centered. The big thing here that might be controversial is who here sort of redactable blocks? Redactable blockchain? Okay. Anybody like nerd fights? Go back to about August of 2016, when this was first proposed. You'll probably find it under Accenture. People flipped out when this paper was published on redactable blockchains. Because people said, if you can change data in a block, you've destroyed the notion of a blockchain. Not necessarily, okay? We can go into the details later offline if you want to. But we're proposing a redactable block. The patient gets a block, and the patient continually modifies the block. Now, why would we do that as opposed to the transaction-based? Well, first up, what's the transaction-based, if you don't know? So in cryptocurrencies, every time you spend some money, there's a transaction that goes in. And if you send it maybe a month later, you're 20 blocks later, you got one